definitely a day. I wish we had color copy machines for the notes, okay?
You said that every day.
I do, I swear I say that every day. Especially today, because it's a throwback to geometry. Remember, I think it's chapter 10 in geometry, where you talk about tangent lines, chords, secants, all of that good stuff. Remember it? I like it, Kale. So today we're going to specifically talk about tangent lines and how you can use limits to calculate the slope of tangent lines. We're going to throw in the word secants also for you too. But like I said, this is really a day I wish we had color copy machines, because you're going to see these different lines on here in different colors and what's happening. And I think it's very hard to tell on your notes with just everything in like a gray scale. So maybe for sure, especially like when we talk about these graphs, take a look at these. Like I said, today the math really isn't that hard or that crazy, a whole lot different than yesterday, but there's a lot of kind of setup work to get to it, okay? So, without further ado. So we're gonna, like I said, we're gonna take a look at how limits can help us find tangent lines. Now, tangent line, mx plus b. I'm already thinking like y minus y1 equals m times x minus x. I'm thinking about all the stuff I know about lines, okay? Graphing lines, slope of lines, y-intercept a line, everything about lines, okay? And we're going to use those two to help us define, really that's tomorrow, we'll get into it a little more. Instantaneous rate of change, it's called. Sounds very fancy. Now, again, here's where I wish we had a color copy machine. Mine's in red there. You can see the tangent line in red. Remember that a tangent line touches the curve. And you can see mine in red. Now, throw it back to geometry. There's that whole entire chapter where you have the circles, and maybe you have a tangent, or maybe you have a secant that goes through it. Remember all of that good stuff?
Yeah, we're trying to do that.
So, man, I miss geometry. Okay. Now, like I said, it's going to be easy today, but there's a lot of setup work to it till we get to the actual math. So, we want to find an equation of the tangent line. Now, just like any time I need an equation of a line, one of the most important pieces is the slope. So we're going to talk a lot today how you can use limits to help us find the slope, okay? So the problem is when we normally do slope, y2 minus y1 over x2 minus x1, you have two ordered pairs. You're not going to have two ordered pairs today. You're only going to have 1 point. So that's where the play of the limit's going to come in to help us with that. So again, you can see here, we can kind of do an approximation. If you pick a point, this is the one they're talking about, and of course we're on the parabola, hence the x squared here. If you pick a point on the line and we calculate the slope. So we're doing, of course, y1 minus y2, x1 minus x2. So you're just doing your boring, rise over run here. Now, we've looked at expressions like that yesterday and doing the limits of that. And that's really what we're leading us to and what we're going to be working on. Again, math is pretty easy. It's all the setup. This is where I really wish we had color copy machines, because you look at the pictures and they all look the same on yours in the grayscale. So if we let x from the right approach it. So we're looking at this coming to the point. So really what's happening, and again, it's hard to see on your notes, I'm looking at these blue and the red lines. Is Q, point Q, is moving closer to P. Closer to P, closer to P. You can see you're getting these blue and red lines are getting closer and closer to being on top of each other or matching. That's what we're talking about limits. As we approach from the right, or of course, if you flip the page, approach from the left. So here you can see as it moves across the screen, I'm looking at the blue where Q is, as we approach from the left, it's getting closer to P. You can see the blue and the red start to match up a little bit more. So that's where the limit comes into play. We're going to approach from the right, approach from the left. That's really a limit. Okay. So the slope of the tangent line, I think I've said limit about 10 times already, is the limit of the slopes. So just like past couple days, my friends. So here, remember, we had the parabola, the x squared. We had this all set up. Let me click it back a couple. We had this all set up. So what I'm going to do now to get the slope is I'm going to do the limit of this, which we did yesterday. Now, I can't go direct substitution, because if I put 1 in, of course, 0 under the line. Doesn't mean we go straight automatically to DME. Means we might have to simplify. The top can factor. You have difference of perfect squares up there. And then, of course, I'm going to cancel out the x minus 1s. Now, from here, most of you can probably have an answer. Now you can use your direct substitution. What's your final answer? Nice, easy number.
Dose.
Dose. Man, our Spanish really is getting good in here. Okay, 1 plus 1, 2.
It's actually making me better, I think.
So that would be the slope of your tangent line. So that's how we're going to calculate it today, is with limits. Now that you know the slope, of course, they're going to want the full-on equation. Remember, we've got our slope of 2 that we just got from our limit answer. And remember, on that page, we were going through this point. So I'm like, okay, well, I can get an equation of a line if I know a point and slope. I'm going to use point slope form. Y minus the y coordinate, the slope, x minus the x coordinate. I'm going to distribute, I'm going to combine my term, blah, blah, blah. I'm going to do all this stuff, So 2 times x, 2 times negative 1, and let's just add 1 over. So now I have that equation of my red tangent, mine's red of course, red tangent line. Now, one thing I'm going to show you on your graphing calculator here is this. Sometimes we refer to the slope of the tangent line to a curve as the slope of the curve at the point, of course. The idea is, if you zoom in, I don't know if you know how to zoom in on your graphing calculator, I'm going to show you that. If you zoom in enough, it almost looks like a straight line. So, pull up your calculator. Give you a sec. You want to borrow one, Owen? You're welcome to grab one there. Okay, I'm going to graph our, we know what x squared looks like. You can see I typed it in earlier. I got some other stuff in for what's coming at us. So just do your x squared. We know it's the parabola. There it is. Very exciting. Okay, so what we're taking a look at, of course, so it says to graph it, and if you zoom in at 1, 1. Now I'm going to show you how to zoom in, okay, first off. So I'm just going to go, I'm going to go ahead and hit trace first off. I'm just going to kind of cursor over there so I'm close to it. That's a little far maybe. A little far. Got carried away with my cursor. Close enough to 1, 1, close enough to 1, 1. So then I'm going to hit a zoom, and I'm going to just do number 2 in. And I'm just going to hit enter. And it blows that up. I'm going to hit enter again. I mean, I can stand up here and do this all day. And it looks like a line now, because I kept zooming in, zooming in, zooming in. And when you keep doing that, it looks like almost, keyword almost, like a straight line. Not quite, don't get me started on my hatred of Texas Instruments, but that's why we can approximate the slope of the line. Now, I've clearly just messed up your viewing window, so let's change it back to our normal 10 by 10. So I'm going to hit zoom, the top, and number 6. And there's our lovely parabola again. So I didn't know if you knew how to zoom in, but I just wanted to show you that. If you zoom in enough, of course, it can almost look like a straight line. Moving on, my friends. So, when we have a curve, of course, what we're going to do, we want to find the slope of the tangent line, and then, of course, we're going to find the equation of the line. So if you take a look, this notation I recognize all looks super crazy with all the letters, but it's literally rise over run. So I'm constantly thinking today, y2 minus y1 over x2 minus x1. This is just the fancy, crazy notation we're going to use to calculate slope. But of course, it's not just through nice ordered pairs. It's going to be a little step up for us today. Okay, same thing. We're going to be doing the limit, just like we saw, to calculate our slope. And again, the notation looks crazy. y2 minus y1 over x2 minus x1. And you'll see it makes a lot more sense when we have actual real numbers and equations. So let's do one, okay? So if you graph it, which we're going to look at the graph here in a minute, find an equation of the tangent line to that hyperbola at the point. So whenever we do slope, I, of course, like ordered pairs. So I'm going to work on my slope, of course, first thing. First and most important thing whenever you have to write the equation of a line. So, of course, my slope. Now, our function is 3 over x. So I'm going to write that out ordered pair style. We're going to put x in, and our y is the 3 over x. Just like if I said if you put 1 in, what's y? 3. You put 2 in, 3 halves. 4 in, 3/4. That's how you calculate it. Then we get our point. So I'm just going to calculate slope like we always calculate slope. But remember, for us, it's not just going to be that. We have to do the limit as we get closer. Now, we're going to, x approaches, x coordinate of our point, we're looking at 3. Now, I'm going to do my y. I'm going, just because I don't want to have a bunch of negatives, and plus I like it to look this way, I'm going to do y1 minus y2, x1 minus x2. And again, you could have it 1 minus 3 over x, 3 minus x. You just have some different signs, but it's all equivalent. I just like it to look this way. Now, just like yesterday, I can't just direct substitute because 0 and 1 and fine. So I'm going to use an alternative form. I'm going to simplify it a little bit. Nobody loves a fraction in here probably except myself. So I would say let's clear the fraction. I'm going to get rid of the denominator x. But of course I got to do the bottom by x. So I'm still simplifying here. Limit x approaches 3. I know it's so fun to write. So if I times everything by x, that's really what we're taking a look at here. So I'm going to have x times 3 over x. The x's would cancel. Negative 1 times x. So we got rid of the fraction, which is kind of what we were hoping for. And it doesn't matter if you distribute this or leave it or whatever. I'm just going to leave it x minus 3 times x for right now. You could put the x in the front. Now, we're close. Because this, they're not quite the same, but I can simplify them. They all have opposite signs. So it's not going to simplify to 1. It really makes negative 1. 5 over negative 5. 10 over negative 10. They're all opposite signs. So I'm not going to cross, I'm not just going to straight cross it off because I don't want it to look like that. I'm going to make it negative 1. So I'm going to have negative 1. And you still have that little baby bottom outside x there. Now I can use my direct substitution. You got it. What is it? Negative 1/3. Now, that was all just to get the slope of it. We need the equation of the line. Well, okay, fine, whatever. So I'm just going to use my point. I'm going to use obviously the nice, pretty easy 3, 1 with my slope and use my point slope form. Y minus the y coordinate, or scoop, x minus the x. Of course, I'm going to distribute, combine the like terms, do all this stuff. So negative 1/3 x. What's negative 1/3 times negative 3? 1. And I'm going to add 1 over. Got it. So here's what we're going to do. Get out your calculators. We're going to check this. We're going to prove that this is all simpatico. First thing I'm going to do is just graph our given function. I'm going to graph the 3 over x. Let me pull up my calculator here. Clear it all out. I got all sorts of stuff in here. Who knows what. Okay, so I'm just typing in the original one, 3 over x. I'm going to take a look at it. 3 over x graph. Yeah, that's fun. That's what I expected it to look like, a rational function. Now, I'm going to graph our line also on here in the same screen. So I'm going to hit y equals, so my y2, I already forgot, what's my equation? I'm going to type in the blue one, negative 1/3 x plus 2. Let's graph that also. I just like the horizontal fraction bar. That's how I roll, you know. Okay, we're going to hit graph. And as long as we have not messed up anywhere, which we would never do such a thing, where are those two going to intersect at? They better hit at 3, 1 or something as a rod. How's it looking? Here it comes. Bam. I mean, it looks like it hits at 3, 1 to me. Okay, just as a ballpark. But let's double check on the table because you know Texas Instruments don't here. Oh yeah, 3, 1. Looking good, friends. Looking good. So that is always a quick way too. You can double check it if you're a little worried if anything is off. Okay. So nice, quick way. Alex, question? Oh Lord.
I definitely did something wrong.
Oh boy. Alex. Now.
What'd you put in the calculator? Show me what you put in the calculator. Oh yeah, I did it plus 2.
He just didn't add 2.
Come on, Alex.
Where did 2 come from?
Are you kidding me?
not listening at all?
Oh, I get it now. I
It's
get it
'cause you
now.
didn't speak
Okay,
in
wait.
Spanish.
I didn't say it in Spanish. I should have said it in Spanish. I
No,
don't.
I actually subtracted.
Como se dice 1/3 in Spanish? Anybody? Uno. You got it? Okay. Okay. Alex is all set. Okay. Now, this looks so crazy. You're ready for this one. So here's the next problem we have to deal with, which is this craziness, okay? Which it does look crazy, I'm not gonna lie. Now, majority of the time, okay, and you'll see when you check your homework, I started off with this route. Super easy, I just slap down my point, my function, little y2 minus y1, and I work on the limit. But, as you have seen, sometimes, if you try to do that, you can't factor, direct substitution, it turns into kind of a nightmare. That's why we have an alternative way for you too. Okay, there's another expression for the slope of a tangent line that's sometimes easier to use. This to me looks like a foreign language when you just take a look at it. Let h equal x minus a. This isn't on your notes because of all the colors. I'm like, there's no way you're going to tell what's happening here. Then x equals a plus h. So the slope of the secant line is this very lovely expression. So I'm going to show you how to do it through this way too. So your limit, of course, h approaches 0, that's going to stay. A is really, they're just offsetting a instead of x. You're going to use the x coordinate of your point here. So whatever that is, f of x of your point over h. So don't write this, okay? Because I'm going to show you the why. Why do we have this other weirdo way? Let's say I was just like, oh, forget that last slide. I'm just going to do it like the first one. So I'm going to have my ordered, don't write this, and then my function. And my point. So it's like, cool, I'm just going to do the limit, don't write this, for my slope,
Wait, we are?
don't write it, you're approaching 1, your x coordinate, and I'm just going to do my y2 minus y1 over x. Now here's the problem. Yeah, I know this is 1, we can combine it to 1, but what are you going to do from there? How are you going to factor x cubed minus 2x plus 1? Yeah, we're stuck. Are you kidding me?
They both wrote all of it.
Okay.
Oh.
So that is why I'm going to click it back, maybe here. We're going to use this. Like I said, I like to use that first example one. 90% of the time it's straightforward and works out like the first example did. Slope, y2 minus y1, x minus y, bam, it's easy. Not so much though like this last problem, so I'm going to use this craziness. So first thing I'm going to do is just set it up. I'm really writing all of this, okay, but instead of a, you're using x. That's the difference, so here we go. Start writing, you can actually start writing this.
Yeah, guys.
So h approaches 0. Listen to that, yeah guys. Okay, now, so remember, RA is really they're using it in place of 1. So when I click the slide, you'll see your x coordinate on the point is 1, so I'm going to have 1 plus h, f of 1 plus h minus, because we're subtracting just like slope, f of 1 over h. This is another way you could do the slope. This is way more time consuming and more of a pain, but you can see I tried the other way and I hit the wall, okay? Now, a couple things we're going to have to find here. Probably should have wrote smaller, I don't know, we'll see. So to calculate f of 1 plus h, just like any time you do a function, we have to put 1 plus h in for all of these x's. So I'm like, that's why I said I probably should have wrote smaller. So I'm going to have 1 plus h cubed. That's brutal, I'm already groaning. 2 times 1 plus h, and then plus 3. Okay, f of 1. I think we could do f of 1 in our heads, okay? If you put 1 in for x, that's going to come out pretty nice, I think. 1 cubed minus 2 times 1 plus 3. What's that? 2. And of course we have over h. Now, I can't direct substitute yet. That's what we want to do. Because of course if I put 0 in here, 0 on the line, but so we got to keep working on that nightmare mess of the top. I feel like I can already tell I'm going to have to extend the slide. I'll fill in the bottom part. Now, let's work smarter, not harder. 1 plus h cubed. Choices. I could write 1 plus h, 1 plus h, 1 plus h, and stand up here and FOIL. That's too time consuming. We know binomial expansion from last chapter.
Oh my gosh, we do.
Yeah, I'm going to use binomial expansion on it because I think that's easier, okay? I'm just going to give you the coefficients. It's 1, 3, 3, 1. I don't even know where to write this. So if you're doing your Pascal's triangle for your third power, this would be it. Okay, 0, 1, 2, 3, yeah. So I'm going to have 1, my first coefficient. So many ones. First term of your binomial is 1, so 1 to the third, h to the 0. I'm not writing h to the 0 because I'm already going to run out of room. 3. For my next coefficient, 1 is down to the second, h is at the first. 3. 1 is down to the first, h to the second. 1. 1 is down to the 0. I'm not sure that's really even worth me writing. H to the third. Okay, I still got to take negative 2 through here. Minus 2, minus 2h. I've got plus 3 and minus 2 here. I'm going to move it up. Move it up a little bit. Let's combine all of those terms that we can. Are you having fun yet? Limit h approaches 0. Okay, here we go. So of course, I have 1 and 1 here really. 1 cubed 1, right? 3, 1, h, 3h. 3, 1, h squared, 3h squared. 1h cubed, I'm just putting h cubed. Let's see if I can combine some of this number stuff here. I still have the minus 2h. And I'm going to put minus 2 plus 3. So I'm at 1, 1 minus 2. I still think we can clean up the top a little bit. Agree?
No.
Yeah, we can. The 1's cancel. And I'm going to put the 3h minus 2h together. And this is just me, and this irritates me that they're in a weirdo order. I'm going to put the h cubed first because that's how I like it. I'm going to put the 3h squared. And then I'm going to do the h's. 3h minus 2h, 1h.
Are taking h out too.
And then you're on my next step. I'm going to reduce everything down by h because I still can't do direct substitution. And you know, I probably should scroll it up again so I'm not clear at the bottom. All right, just like Alex said, I can't believe those words just came out of my mouth. We're going to take h out of everything. Woo. So I'm going to be at h squared plus 3h plus 1 all over h. Now we did all of that work
To get that.
to get a final answer of
1.
0, 1.
It's just 1.
because if we put 0, if we direct substitute, we put 0 in.
Every.
Now, people, my people, we're still not done. That's only what part of the equation of the line? The slope. We need to write out the full-on equation, which, remember, the point, just look at the top. The point it goes through is 1. Was 1 comma 2. So now I'm going to use my point slope form and we'll be done. Okay, so we end up with y equals x what? Plus 1. Wasn't that fun?
No.
So very fun. Now, okay, couple of things. Let's recap. Let's just recap it. 90% of the time, it's very straightforward like this one. Just write out the points, limit, slope, bing, bang, boom. It wasn't that horrific. Then, I tried to do that on this, but remember, I hit the wall where I couldn't factor it. I couldn't go anywhere. I was stuck. So I had to do this. Let's just call it what it is, hellacious process, okay? But like I said, it's only 90%. Now, okay, I'm gonna be honest with you kids, as always. I might have got a little overzealous on the homework.
Is it 4 pages prior? Are you serious?
I did.
It's serious right now, bro. Are you serious right now, bro?
So, I don't know why. I really did get overzealous on it. So here's the thing. There's 4 of them. I'm going to jot down, that's on my hot post-it note here, that you can skip. Okay? Because even I felt it was taking me a long time to write out the key for all of it, and it was getting out of control. Plus, I want to talk about the blue part, okay? So first, let's throw this on here so we got it. Okay, I must be losing it clearly at the end of the year because I listened to Alex and decided to make your quiz a take-home quiz.
I've never told you to do that.
I think you were excited about it when I threw it out there.
That was your
And I
idea,
must have
guys.
zeroed in on that. I don't know. I'll let Alex influence me.
You're welcome, guys.
So I do have
I
your
just
take.
not had a quiz.
God help me. I do have your take-home quiz made, and I'm going to give it to you today over 13.1 and 13.2. Is it crazy hard because it's take-home? No.
Yes.
No, it's not. It's
What
not
does
at
it
all.
do?
It's a front and a back. It's not that big of a deal. But that is my question for you about, I don't know if you heard Avery asked when is it due?
Monday.
I'm a busy boy.
I'm worried about saying tomorrow because I'm worried this homework might be a little
Monday.
So I was gonna see like Monday.
Yeah.
Monday.
Cross-practice.
What's Monday?
Shut up.
Monday. Anybody? What's the date on
It's
Monday?
the 15th.
Okay.
It's the 15th, sorry.
Okay.